All right, so now we're on to our third periodic trend. This is probably the weirdest one and the hardest one to kind of get a handle on. So you might want to listen to this a couple times. So we are dealing with ionic radius. We're actually down here. We're doing this last one. I can explain the trend for ionic radius and use to compare atoms. Okay. So here's an ion size. You're going to see this picture a lot. The big thing to remember is there's trends in the periodic table. So every one of the first column of the periodic table ends up being a +1. Every one of the second column ends up being a 2+. This is skipping the transition metals. These guys are 3+. And then most of 4A can be a 4+. And then after that, so if you remember positive ions, which I can't spell apparently, positive ions are known as cations. So we'll say cations a lot in here. Remember, positive means a plus, and there's a T in cations, so it's like positive. And then this way, as you continue now, after carbon, this column, they start becoming negative. So this is a 3-, and this is a 2-, and this is a 1-, okay? And so negative ions are known as anions. So we're going to be using both of these terms a lot. Cations for positive, anions is negative. So we got to remember, an ion is an atom that has either gained or lost electrons. So when we say ion size is what happens to the radius of an atom when it becomes positive, loses electrons, or becomes negative, gains electrons. So metals, if you remember from the very first thing, metals are primarily on the left-hand side of the periodic table. Metals have low ionization energy. They want to get rid of their electrons. They want to lose electrons. Losing electrons makes them more stable. So they get smaller, okay, because they've lost electrons. And you remember from the atomic radius presentation, the size of the atom is due to the attraction of the protons in the nucleus of the atom pulling on the electrons, okay? So if you have less electrons, you get pulled in even closer, okay? Nonmetals, on the other hand, have high ionization energies. They don't want to lose electrons. They actually want to gain electrons. So they gain electrons, which makes them more negative. And because they've gained those electrons, there's more electrons that are kind of helping, the electrons are repelling each other, and so they're actually pushing away. So it actually ends up making the nucleus of the atom, or make the radius larger, okay? So nonmetals are larger as they gain electrons, because they've gained electrons. So that's what we're seeing on this chart. Lithium starts out this size, and they get smaller because you're losing more and more and more electrons to get smaller. Then you get to nitrogen. Nitrogen has gained 3 electrons, so it suddenly jumps up in size. But then as you keep going, you start to see they get smaller again. So this is the big one. Going down the table is easy. Just like with atomic radius, as you go down the periodic table, the radius goes up. So going down, lithium is smaller than, or sodium is larger than lithium, potassium is larger than sodium, rubidium is larger than potassium. This is just like atomic radius. And also, just like atomic radius, as you go from left to right, the radius does decrease. However, there's this spot right here where you go from having cations on one side to now having anions on the other side, where the radius jumps up. So the radius is going down and it goes back up, but then it starts going down again. So the overall trend is still that it is getting smaller. The ion size is decreasing as you go from left to right. You just have to remember why there's suddenly a jump in size when you get to between carbon and nitrogen, the 4 column and the 5 column. And that's because you go from having cations, which are losing electrons, to having anions, which are gaining electrons. So I want to show this picture. I like this picture. The red on this side, the red is the size of the ion over here. So the red is the ion for the cations. And the gray on both of these, gray is the original size of the neutral atom. So you see what happens. The size, because it's lost one electron, the size of lithium, of the ion, is smaller than the neutral atom. And they keep getting smaller, so the red ones get smaller. Now, when we get over here, now you have oxygen, which has gained 2 electrons. Gaining 2 electrons causes the radius to go up, okay? Because it's got more electrons pushing out. So the trend goes down, jumps back up, goes down, but the trend is still there. That as it goes down, it is the ionic radius is still decreasing. Okay, you just have to remember there's that weird little hiccup. Okay, that means that anions in the same row are bigger than cations. Okay? But the difference as you go down is still greater. So, yeah. So that's what this picture is. Anions in the same row are bigger than cations, even though the trend is still for the ionic radius to decrease overall. And then the trend going down, so remember, trend going down, no matter what, because you're adding more shells, the radius gets bigger.